in this video, I'm just going to go over some very important notation. So let's say, for example, I have some function f of x, and on this function there's some point, let's say it's 1, 2, okay? And this function is transformed by, let's just say, f of x plus 1, which means that we shift to the left by 1. And if we shift to the left by 1, which means that the x values decrease by 1, so this point 1, 2 gets transformed to 0, 2. So what I want to basically define is like this right here, the 1, 2, this is the original point. This is the original point, okay? And this point is not really, the 1, 2 does not actually become 0, 2. This is what it becomes after a transformation. So on the original f of x, 1, 2 actually stays intact, and f of x plus 1 is just a transformed function. It is another function. And this point right here, after it has been transformed, is called the image of the original point. And the word that I want to focus on is image, right? So you'll quite often see in many questions the word image comes up. So for example, they'll say there's a point A, which is, again, let's just pick the same thing. So let's just say it's 1, 2, and it's transformed by something, and it becomes A prime, which is the image of A, which means it's what it looks like after the transformation. And the key word image I just kind of want to emphasize is like when you look into a mirror, do you see yourself or do you see an image of yourself? In fact, you see an image of yourself. It is quite impossible to see yourself. When you look into a mirror, you actually see an image of yourself. And the same principle works in transformations. When you have a point, and after you transform it, what you get is not a what you get is not that the point has moved to that, is that this is the image of the original point. So very important to emphasize this language as image. And that's it for this video.